Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we'll solve a couple of problems involving projectile motion. Now, the equation that governs projectile motion is this one: S equals negative 16t squared plus v sub 0 or v naught times t plus s sub 0 or s naught. S is the height at time t seconds. V sub 0 is the initial velocity of the projectile. S sub 0 is the initial height of the projectile. So one quick pointer: initial velocity, that's always going to be in units feet per second. That makes it a little easier to find. The initial height is also given in feet, as well as the height that we're interested in. And the ground is equal to a height of 0 feet. Number 12, a tourist is standing on a cliff above a beach. She throws a rock upward at a speed of 70 feet per second from a height of 90 feet above the beach. How long will it take until the rock lands on the beach? Round to the nearest tenth of a second. All right, so we've got the initial speed of 70 feet per second, that's v sub 0. And her height is at 90 feet, that is s sub 0. We want to know, when does it land on the beach? That's when its height, s, is 0. So we have everything from that equation except for the time, and that's what we're going to solve for. So I've got the equation written at the top of the page. I'm going to substitute in here. S is 0. That equals negative 16t squared plus, I'm going to put in 70 for v sub 0, so plus 70t plus 90. Now, working with a quadratic formula, which is what we'll use almost every time here, is more challenging when a is negative. So we would like a to be positive. There's a couple of things that we can do. We can move everything to the left side of the equation. That would change all of those signs. And we can factor out a negative common factor. And I'm going to use that approach this time. Notice that 16, 70, and 90 all have a common factor of 2. So I'm going to factor out a negative 2 from all of those. 0 equals negative 2 times the quantity 8t squared plus, minus 35t minus 45. Now I can go to the quadratic formula using 8 for A, negative 35 for B, and negative 45 for C. T equals the opposite of B plus or minus square root B squared minus 4AC all over 2A. T equals the opposite of B, the opposite of negative 35 is 35, plus or minus the square root of negative 35 to the second power minus 4 times 8 for A times negative 45 for C. And that's all over 2 times A, or 2 times 8. Simplifying inside the square root, we have t equals 35 plus or minus the square root. Negative 35 to the second power is 1,225. Minus 4 times 8 times negative 45 is plus 1,440. And that's all going to be over 16. Finally, t equals 35 plus or minus the square root of 2,665 over 16. And now we can go to our calculator. Here, I'm not sure about the one where we're subtracting the square root, so we're going to have to try them both. 35 plus that square root and 35 minus that square root all over 16. And we'll check those two out. Since we're talking about time, the answer is going to need to be positive. Let's switch over to the graphing calculator. Let me clear the last video's work. And I start with a fraction. And I'm doing the first one. So 35 plus square root 2665. I tap in the denominator. That was 16. And there I get, do we want those to the nearest tenth again? Nearest tenth of a second. So that was 5.4. Let me write that down before I forget it. And to check the one where we subtract, I can just tap back into the numerator, backspace over the plus sign, put in a minus sign instead, and there we see it's negative 1.0. And that's impossible for time. So I'm going to throw that one out, and we're left with 5.4 seconds. That's how long it's going to take to land on the ground. So quick reminder of the formula we used. We substitute values in for s, the initial velocity, and the starting height, and then we solve typically using the quadratic formula. And again, rewriting the equation so the first coefficient, the coefficient of the squared term is not negative, is a really good idea. Because if a is negative, then your denominator is negative, and it becomes a lot more challenging to work through the quadratic formula. We're going to try one more. A projectile is launched at an initial velocity of 36 feet per second. There's our initial velocity. From the top of a building that's 15 feet high, that's our initial height. When will the projectile be at a height of 30 feet? So that is my value for s. And this time we're going to round to the nearest hundredth of a second, or 2 decimal places. So again, I'm going to write the formula down first. S equals negative 16t squared plus v sub 0 t plus s sub 0. I'm going to put in 30 for s. We want to know when is it 30 feet above the ground. Equals negative 16t squared plus 36t, putting in that value for the initial velocity, plus 15, putting in that starting height. So we need to get everything together on one side, and I think it's going to be easier to move everything to the left-hand side so that the coefficient of the squared term is positive. So I'm going to add 16t squared to both sides. That's going to give me 16t squared on the left. I'm going to subtract 36t from both sides. That's going to give me minus 36t on the left. And then I'm going to subtract 15 from both sides. 30 minus 15 is 15. So this is the equation that I need to solve. There's no common factors, so I'm just going to jump right into the quadratic formula. T equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. T equals the opposite of negative 36 is 36 plus or minus the square root. B squared is negative 36 squared minus 4 times a, which is 16, times c, which is 15, all over 2a, or 2 times 16. Okay, some simplifying to do here. T equals 36 plus or minus the square root. Negative 36 times negative 36 is 1,296. You can verify that on your calculator. Minus 4 times 15 times 16, that's minus 960. Again, verify on your calculator, over 32. T equals 36 plus or minus the square root of 336 over 32. And now we can go to the calculator. We're going to have to approximate both of these solutions. So I'm going to do 36 plus that square root divided by 32, and 36 minus that square root over 32 to see what we get. Again, this time we're looking for the nearest hundredth. So let's go to the graphing calculator. And I'm going to start with the one where I'm adding in the numerator. Fraction button, 36 plus square root 336. That's my numerator. The denominator is 32. And over to the right, I see 1.697. That's 1.70 rounded to the nearest hundredth. I'm going to do the one with subtraction just by tapping into that numerator, backspace, change that plus sign to a minus sign, and there I've got 0.55. I've got two possible solutions. Is that possible? We'll have to talk about that. But let's write those down. So again, the first one was 1.70 seconds, and the second one was 0.5 seconds. And the question is, are both of these right answers? And the answer is yes, they are. So here's the situation. Let's go back and look at it from the top. It was launched from a building that was 15 feet high, and we wanted to know when it was 30 feet high. So a really crude drawing. Here's your building that's 15 feet high. Here's a line in the sky that's 30 feet high, and the projectile is going up and back down, and it actually is going to cross that height at two different times, one on the way up, one on the way down. That's why we have two solutions. Is it possible that we would have less than two solutions? Sure, you could get one solution if that apex, its highest point, happened to be the height we were looking for. And you might get zero real solutions if it doesn't reach that height. And so how would we know that? Inside the square root, that discriminant would be negative. And that means that there are no real solutions. All right, that does it for the projectile problems. I hope that's helpful. We'll move on to the next section after this.